How to find the confidence interval for mu1 minus mu2 for the difference in means when the population standard deviation, sigma 1 and 2, are unknown. So when they're known, we use z. When they're unknown, we use t. Okay? So we got to get their sample means and then get our sample standard deviations, our sample sizes, and then we can use this formulas. I'll do it in the calculator, and I'll show you how to do it by hand. So we've got it. Let's kind of skip through some of this. Talking about dreams, brain waves. Slow brain waves are range of 4 to 8 hertz. During normal sleep, they go through several cycles. The book comments that alcohol is a poor sleep aid. In one study that has given a half a liter of red wine before they went to sleep. The subject falls asleep but did not remain asleep the entire the night. Towards morning, between 4 and 6 a.m., they tend to wake up, have trouble going back to sleep. Suppose a random sample of 29 college students were randomly divided into two groups. The first group was given a liter of red wine. The second group was given no alcohol before going to sleep. Everybody in both groups was asleep at 11 p.m. The average brainwave activity was determined by each individual in the group. Determining the brainwave distribution of each group is mound-shaped symmetric, so it's normal. Okay, so there's your data there. So the first thing they're going to ask you here is they're going to ask you, what is the population? Are the samples dependent? Okay, and so we'll check that. So the population, I guess we would say the population would be like, I guess, of college. Where does the sample represent? It looks like it represents college students here. We're talking about sleeping habits of college students there. Let's just talk about the samples if they're independent or dependent. So basically what happens is they randomly assigned one group to drink the red wine and one group not to drink the red wine. And so this one they would call this one independent because we basically one would not impact the other. So we would say the independent because they were randomly assigned to separate groups. Okay. To separate groups. So this one would be independent. If they try to pair them up in some way, that would be dependent. Or if they try to do like a before and after type of thing. So the t distribution, is it appropriate to use the t distribution? They're independent. We also know it's mound shaped and symmetric, so it's approximately normal. Mound shape and symmetric, so it's approximately normal. All right, so we can use that as well. So we're good. We should be good to go here. And we don't know the population standard deviation, so we'll use the t distribution. Okay, compute a 9% confidence interval. All right. So basically what you're going to do here is if t is known, if the standard deviation, the population standard deviation is known, we use z. If it's unknown, what do we use? T. Unknown. So we're going to use, unknown. I meant to say unknown. Unknown, we're going to use t. Unknown. So we're going to use t. Okay. So you're going to use the two sample t interval here. So we're going to go to option 0. I can write this down. Stat, test, 0 to sample t interval. Okay. It's stats again. So x bar 1, and I'm going to read this off. I've got another copy of notes here. X bar 1 is 19.65. S of x1 is 1.86. Okay. Let's see. N1 is 15. This all given to you right here. N1's 15. They give it to you right there. So I'm just copying this, but I have another set of notes, so I can copy this. X bar 2 is 6.59. 6.59. S of x2 is 1.91. And then N2 is, I forgot to put the N there, but that would be, it looks like 14. 14, yeah. I didn't put it on the bottom, but it's 14. And then the sea level, it's 0.9. 9. Okay. Now, for pooled, we should assume that it's not pooled here. You're going to put no for pooled. Pooled no, and I'll explain that here in a moment. So all I'm doing here, so I know it seems like it's very complicated. It's not that bad. All you got to do is type in the stuff. 1.86, 15, 6.59, 1.91, 14.9, no for pooled, calculate. So I get 11.866 and 14.254. So 11.866, 14.254. So that's my lower bound, upper bound. Okay, so we'll say we are 90% confident that there's a lot of ways you could do this. We're 90% confident that the interval between 11.866 and 14.254 contains a difference, contains the true mean or true difference in means and brainwave activity. So I'm going to kind of stop there. I know this can get kind of in the weeds here, but basically what that means is that the group 1 was bigger than group 2. So group 1 had the alcohol, group 2 did not have the alcohol. So for it to be positive, alcohol minus non-alcohol, the alcohol has to be greater. So that means basically the ones that drank alcohol had higher brain waves, and so I guess that affects their sleep. So that's all you need to know. I'll show you how to do it by hand, but as I said, don't worry about having to do this. You can ignore this if you want. So how do you do this by hand? The confidence interval formula. I'm going to write this over here a little bit. So it's basically, first thing I want to do is find the error. The error is the critical value of t. This is a pain to do by hand because it's not always as accurate. And 2. Okay. Now, the degrees of freedom here is, well, here's the thing. It's a long, complicated formula. And so the real degrees of freedom is this. This is why doing it by hand kind of not much fun, or it's not great because, but if you're doing it by hand, you want to take the smaller n minus 1. So I've got 2 n minus 1s. I've got n minus 1 for 15. So n minus 1 for that would be 14. N minus 1 for that would be 13. So you're going to take the smaller n minus 1. So the smaller n minus 1 degrees of freedom, my smaller n minus 1 would be 13, which is going to give me inaccurate information, a little inaccurate here. So I'll do inverse t. So if I'm doing a 90% confident, that means 95% is below it. 13. This gives me the critical value. Inverse t, 0.95, 13, 1.771. So 1.771, and then I'll plug that in there. That's going to make this a little bit more accurate. That's why technology is better on this one, because this is not going to be very accurate. 1.86 squared divided by 15 plus 1.91 squared divided by 14. So times. So I would not do this by hand. Squared divided by 15 plus 1.91 squared divided by 14. 1.241. Then I'll do the differences in the means. X1 minus X2, which is 19.65 minus 6.59. As I said, you do not need to know any of this here. 13.06. So basically what I'm going to do next is it's going to be this, the differences in means, this plus or minus the margin of error. So 13.06 minus 1.241, 13.06 plus 1.241. And so you get an interval that's not near, actually it's not too bad, 9 to 14.301. But I thought it'd be more inaccurate than that. So that's how you do it by hand. I would not do that. Salt will be able to do this for you today.